Good morning, ma'am. Here I am going to talk about the QR decomposition. The QR decomposition using the Grand schematic method is a mathematical technique used in linear algebra to decompose a given matrix A into the product of the two matrices Q and R. Here Q is the orthogonal matrix whose columns are orthogonal unit vector, and R is an upper triangular matrix. The Grand schematic process is applied to the column of matrix A to construct the orthogonal basis that forms Q. This is done by iteratively projecting each column vectors of A onto the previously obtained orthogonal vector and subtracting this projection to ensure orthogonality, and the coefficient of these projections are stored in the matrix R. Once all the columns are processed, we obtain A equal to QR, where Q transfers Q equal to I, the identity matrix, performing the least square approximately, and in various applications of numerical linear algebra where matrix stability and efficiency are crucial. This is the program Python code for QR decomposition. This Python code performs QR decomposition of a user input matrix using the Grand schematic orthogonalization method. The goal is to decompose the matrix A into the two matrix Q and where Q is the orthogonal matrix and R is an upper triangular matrix, such that A equal to QR. The program defines a function QR decomposition that initializes the empty matrix Q and R with the appropriate dimension. It then processes each column of the input matrix. For each column, it calculates its projection onto the previously computed orthogonal vector stored in Q, subtracts those projections to ensure the orthogonality, and then normalize the result to form a new orthogonal vector. These vectors are stored in Q while the projection coefficient is stored in R. The program then prints both matrix Q and R, and the user is promoted to input matrix example 1, 2, 3, 2, such as like that, which is then passed to the function for decomposition. Once correct, the program efficiently demonstrates the Grand schematic based QR decomposition technique. This is the output of the QR decomposition for the Python code. Thank you.